One, I'm going to thank the organizers of the meeting and thank Dr. Haddad for the very comprehensive introduction. One of my other mentees back there, he's like, get on with it, on with it. Come on. I was the same thing. Whenever I always hear this stuff, I always go like, who is that? Who wrote that? I'm not even sure. But today I'm going to talk to you about, this is an interesting topic that George gave me, which is cardiac contractile dysfunction, but also what I'm really going to talk about is mentoring ACIC fellows. I'm going to spend most of my time on that. So when I started many, many years ago, I had actually, my PhD work was really in neurophysiology and neuroanatomy. My thesis happened to have been cardiovascular because the project I wanted to do in neuro was too expensive. I said, okay, fine, neuro, excitable tissue like cardiac, fine. But I knew then that I did not like the idea of inotropes in digitalis. I didn't get the idea that if you go out, the heart's a muscle. If you are an athlete, you go out and you pull a muscle, your trainer doesn't tell you, oh, go run 10 more miles on it, it'll get better. So I really didn't conceptually understand that. I thought the heart should be resting, not working harder. So I took on the goal of reversing end-stage heart failure. Also, being the kind of kid I was, I don't understand this word end stage, the end. I just didn't get it. You know, what do you mean end? I mean, you have heart failure, end stage, you're dead. And that's the way the dogma was at that time. A lot of your dogma that you think now came out of paradigm shifts that resulted from, I will hopefully, and I'm only going to show you 3 slides of my work because I have other mentees here who've done a much better job with the work and have continued the work. Okay, but I'm going to give you a quick 3-section tour of mine. So my goal was simply, end stage, to take the heart, remodel it back to normal. And I've selected this, get ready, let's race. I am from neurophysiology, never took a course in cardiovascular, anything in my PhD program. Okay, but my advisor was very well known for cardiovascular work. So I picked a big fight. Therapeutic modalities. I didn't like inotropic agents, make the heart pump harder. So I decided, no, I'm going to bury digitalis. I came with the sole intent to Harvard Medical School to bury digitalis. It just did not make sense to me, okay? This is the paper. So several things happen, and in your life you have to realize there are things that will happen, not because they're planned, but they're serendipitous. So for example, while I was there, all of a sudden, the Brigham and Women's Hospital developed the human cardiac transplantation program. Great. Also at that time, a person had joined Jim Morgan from the Mayo Clinic measuring intracellular calcium with a bioluminescent indicator in multicellular preparations. Now, there's supposedly only 5 labs in the world that could use this bioluminescent indicator, but really in reality, it was only one. John Blinks's lab, Jim Morgan was in his lab, so when he came to Harvard, he brought the technology with him. Okay, so it's really one. So I have a unique technique no one else has. I have access to human tissues, which no one else had. Okay, so what does that require? Cardiac transplantation. Frederica will tell you the same thing. Roger will tell you the same thing about sitting in the morgue, waiting for the transplant. They run the heart down. They put you in the lab, so you get the heart. And then the whole thing is you get the heart, they come bring it down to the morgue, they put it in a container, and then we had to run it back across the street to the lab. Okay. Now this became critical because what we were observing, first ever recorded intracellular calcium transients, and what I was going to do was challenge dogma to publish something that was not accepted scientifically. So we had to hear things like the tissues are damaged, they're hypoxic, you're studying really malfunctioning tissue. So we did things like racing, literally. They go get the heart, so go. And I would time them. So I could put in the paper, in 30 minutes, we had them back in the lab and, on a buffer solution. Okay, and the temperature of the buffer solution was blah. Okay, this is one of the most cited papers on calcium. So this was the bioluminescent indicator. We're taking trabeculae from the heart. Okay, we're waiting. You never know when you're going to get called for it. But also we need now non-failing human myocardium as a comparator. So what do? We join the New England Organ Bank. They go for the valves. We pick up the apex of the heart. Okay, so we are on these organ harvesting missions as a laboratory. So just to make it kind of simple, with a corn, we'll say this is SR calcium release and reuptake. We know it's a little bit more than that, but that's pretty much it. Okay, so in the control directly, we saw increased uptake, increased release, a reuptake. But in the failing heart, we saw a much slower decline to baseline, and not only that, diastolic calcium was elevated in human heart failure. So that's when I began to say, the heart doesn't need more calcium, it needs a better way to mobilize that calcium. And we started using phrases like calcium handling. It was abnormal. That's why we started to come up with this vocabulary. So then I went on to show them something they'd never seen before. Because this is the first human heart studies, I have to then make an animal model and validate an animal model that reflects this. Because the first thing we got was, that's not what we see in dogs, that's not what we see in rats, this is not what we see in mice. And so therefore we developed, and actually I continued the model that I developed in graduate school, which is an avian model of cardiomyopathy. Well, first, I used to make jokes at the conference. Do you want to be a turkey or a rat? Would you rather be a turkey or a rat? Okay, because everybody wanted to be rats. I was working with turkeys. Okay, and so I had to duplicate. Every paper was two. Animal model first, human tissue next. Animal model first, human tissue next. We just bounced back and forth. Okay, so now we have a precedent. This was reported in an animal model. I know, guess what? We found the same thing in human myocardium. So, and actually when I used to get on buses, when I was going to the Gordon conference, I would get on the bus and all the young fellows would say, oh, there's Miss Calcium, okay? Because no one else could do it. No one else was measuring calcium but me. And so I did a really strange experiment. This is heart failure. The ejection fraction. I could have shown you fractional shortening, but this is ejection fraction, okay? And this just shows you that with time, even they continue to remodel. The heart continues to enlarge. The animals, this is in the avian model and the turkey model, continue to worsen. This is a dose of a beta blocker that restored ejection fraction. Now, I presented this at American Heart at a competition, and no one, at the end of the competition, the judges asked you questions. No one said anything. No one asked me anything, okay? Because then I followed this slide with this slide, and at that time, if you ever thought about saying the word beta blocker in cardiology, you would be sent home as being totally an idiot and incompetent, okay, right? No. And so I did this experiment. And this is a dose that doesn't even lower blood pressure. And lo and behold, it showed a significant increase in survival. So I did a crazy experiment. I showed the crazy data at the American Heart. No one said anything. I remember Mike Bristow was standing. He never sat down. He was standing, and I know Mike. And I'm like, Mike, how come no one said anything? He goes, Judy, no one's ever seen anything like that. You've shown that you can reverse heart failure. And in the finish the story, this lower dose, the non-responders, just like in people with human heart failure, there are non-responders on beta blockers. What we found out, and this was Rongli Liao in my laboratory, she did the myofibrillar ATPase. And so we found that the ones that did not modify or change back the contractile protein activity were non-responders. And the ones that did were responders. Now, calcium cycling here went back. That was normal. Energetics was normal, but the myofilaments were not normal here. Okay? So this study has been duplicated, was duplicated clinically with Mike Bristow when he found exactly the same thing in human studies. So that's all I'm going to tell you about my research. But obviously in the lab, we were working hard, we played hard, because it was a 24/7 operation. We never knew when they were going to do transplants. We never knew we were going to have controlled heart. Okay, we had to handle the turkeys, do echoes on them, and so forth and so on. And so we learned to work hard, play hard, and sleep fast, because we had decided as a laboratory, we were on this fast and furious ascent. We didn't read papers. We didn't care what other people said. We didn't care what they believed. We really didn't. Because at this point, it was about, I always say in my life, we don't test an hypothesis, we ask a question. Okay? And I'll give you an example of this work, how that changed things. A lot of the stuff you read in myofilaments and so forth and calcium, that all came out of this group. It was a young group. I remember one night, Dr. Hajar, who you'll hear speak later, came up to me, 1 o'clock in the morning, I'm in the lab. So he comes up and says, can you tetanize human myocardium? I said, no, you cannot tetanize human myocardium. Go back downstairs, okay? So he goes away. He comes back. How come you can't tetanize human myocardium? I said, because that's written in the books. I teach it. I'm a lecturer. Go away. No, the answer is absolutely not. Go. So he goes away. Now it's about 3 o'clock in the morning. He comes back up. And he looks me in the face and goes, well, have you ever tried? And I said, good point. Very good point. So we did. We went downstairs. And we found out, lo and behold, you can tetanize myocardium. So we found out we could tetanize the myocardium. That changed the physiology book. In fact, at Mount Sinai, they were rewriting that book, the physiology book, that year. We published that paper in Circulation, talked about myofilament force calcium relationships, and all of a sudden that came immediately out of textbooks. We've changed textbooks. We talked about protein kinase C. Roger started actually at the myofilament. It was kind of funny. He was a myofilament person. I was a calcium person. And then as we worked and collaborated, I became more of the myofilament person. He became more of the calcium person. But we just took on any things we did. And that's why I said we never tested a hypothesis, because we didn't know what hypothesis we were going to test. We just did experiments. We just asked questions. What if? Okay, what if we did hypoxia? We showed that just lowering diastolic calcium, that contractility can increase by 5-10-fold. Okay, this stuff was unheard of. And it got to the point that when we would go to American Heart meetings and we were accepted for a talk, people, it was funny. Roger and I were talking about it last night. People would come with their slides blacked out. They would take a marker and black them out. Because we would go first and present our data, then they take a break and they go and scratch up their slides. They didn't want to say what they were going to say because of our data. Okay, so it was quite exciting. That's why I tell you about the goals of ACIC. Okay, it's a very important, very exciting, and I'm very pleased that George asked me to do this. And you've heard some of the Dr. Oki talk about some of them. I'm going to take a little deeper what the goals of ACIC are. One of them is to produce academic cardiologists who are physician scientists pursuing basic, clinical, as well as translational cardiovascular research. And also is to produce cardiovascular scientists who then go on and become pioneers. They take this back to their homes. They become leaders. They become pioneers. And to build an in-depth and lasting international collaborations among basic scientists as well as cardiologists. So the key here is lasting international relationships and collaborations, where you're sharing not only information, you're sharing resources, okay? And to create an environment affording opportunities to share these resources and knowledge, which means joint international grants, international proposals. There was a Fogarty. George and I went to Egypt because I had a Fogarty once about thalassemia, treating kids with iron overload. You come up with the idea, well, we need a collaborative grant. What can I bring to that process? What can I give? What can be my part? Maybe your part might be only, I have access to patients, but I don't have access to the high-end imaging. I don't have access to stem cells. I don't have access to adenoviral vectors, but your part is quite critical and needed for this success. So, this is a picture of the world about pioneers in cardiology. I used to be able to turn it on off myself. And basic science. And basically, all this slide shows you is the world is very, very large. If you can imagine, just imagine, science and life has become what? It's become global. There's no longer little silos. It has become very global. So you have to broaden your research. There are people who have access to tissues, and so far I was in Russia, as he mentioned recently, and they have all the clinical demographics on kids with genetic cardiomyopathies, but they don't have the tools to do the genomics on them. They can do the genetic testing, but they don't have the proteomics and other key basic science aspects to apply to this. The hospital had over 500 kids there. That data, we rarely here have that kind of patient population, okay? They're well documented, and they're looking for what? They're looking for collaborators, okay? So this is my favorite slide. I want you to ask yourself, male, female, whatever, transgender, it doesn't matter, anybody who's anybody. Is the distance the same for you as everyone else? Is it, for the majority population, is this distance the same? Here she is, she starts, she's got a ball and chain on her ankle. She's got landmines, she's got barbed wires, there's an alligator, she's got to jump through their spikes. Yeah, the distance may be the same, but what you the hell have to go through to get to the end of this, he says, oh, stop whining, it's the same distance, is not true. Yeah, the distance is the same, but what you have to do is very much, and I stand here as proof of it, very, very much different. Okay, you have to go through a lot more. So, I want you to know that the future is not a place where you are going. It is a place that through ACIC that you will create. You will create this future. It's not where you're going, you will create it. And actually, it's not about being perfect. It's not about being the best and the brightest, but it is about being present. When we were there, we were present. 24/7 we were present, okay? And so, for example, when Roger worked with me, what he would do, he was a medical student, so he would go to medical school during the day. He had classes. So during the day, I would be doing the experiments. And then in the evening, he would come in and analyze the data. Okay? And then one of the best, the one of the most favorite memories of mine when I was in the lab is that what we would do is when we wrote manuscripts, we would put our feet up on the desk and put the keyboard in our lap. And depending on who wanted to start the paper, who had the biggest attitude about the paper, he might write the first paragraph. We're looking at the monitor. I said, not bad. I said, but what about this? And I'd write my paragraph. But I think blah, 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 blah. And in a matter of hours, the manuscript was finished. And it was so much fun about, even especially when we got to the discussion. He would have his discussion about myofilaments. I would have my discussion about calcium. And so we had to blend this stuff, okay? But within a few hours, our manuscript was done, okay? So, but that was working together that made it a lot of fun. Now, you don't have to be in a huge group. I had a very, very small lab. And I say, this is Gandhi in front of the British Parliament. He's a single man. He cost a king his empire. So I want this film to empower you. In the US, I usually show 5 men sitting together and they're looking over a piece of paper. It was the Declaration of Independence. 5 people cost that king his empire, okay? Doesn't have to be this big, massive group. Doesn't have to be. Small groups can have a tremendous impact. But you have to focus. And actually, the more I looked at this arrow, what I like about this arrow is that as you go further to outside lanes, those of you who are runners or track runners, see it gets wider, 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 because if you're on an outside lane, you have to run further and further. You're running a further distance, right? So this is kind of true, even in your science. Here's a person, Chukwu Kuffour. Chukwu, Nigeria. He's a spinal surgeon. No, Thomas Jefferson, that I had the honor to work with. This is Lily Emmerich, Asian American, and her daughter. They went last summer and worked with the Maasai warrior. She does infectious disease, pediatric infectious disease at Morehouse School of Medicine. And here's one of my favorite ones. This is Mohammed, who I met during one of the similar talks in Egypt. He and I wrote, actually, I helped him write a proposal. He's now funded a fellow and so forth. So this is Mohammed, okay? When I first met Mohammed, he goes, oh, I can't do this, I'm not that, I'm an Egyptian, they're not gonna give me a chance, blah, blah, blah. I said, oh, come on, Mohammed, get over it. Okay, stop the whining. Let's just do it, okay? And he did. In fact, I'm gonna visit Mohammed in September. And here is where I live in Qatar. We have graduates from not only Cornell, we now have Qatar Medical School itself. And these young people are ready to learn. They're ready to collaborate. They're ready to be part, okay? And I'm showing these slides too to say you don't have to look like everyone else to be successful. I don't look like everybody else. I think I was moderately successful, okay? It's about finding the right people and getting them motivated and having the right energy. But the bad news is there are no shortcuts. You're gonna have to do work. If you work for Dr. Del Monte, you better be ready 24/7 because she runs around the clock, okay? It's not a 9-to-5 job. It's not a 40-hour-a-week job. I'm sorry. That's not how you get to be successful. So what are your minimum requirements? Your past record to be part, your past record of achievement. You should have defined career goals, and you should have already kind of thought about a hypothesis-driven project. Now, the important part that George talked about is finding a mentor. And that mentor and your project really do have to interface. You can have a mentor over here and your project over there. It's better that they overlap and there's some synergy. So Roger, this is what I told you about. Ta-da! This is your slide. Listen, to be a mentor, you have to have the energy to drive human potential. I know Frederica has the energy to drive human potential. I think you were saying you needed another cup of coffee. But you have to have the energy to drive human potential, which means as a mentor, I don't care if you call me at 1 o'clock in the morning, I don't care if you call me at 3 o'clock in the morning, 4 o'clock in the morning, if you're having some major crises, not necessarily just in the lab, I don't care. You call me, okay? And I guarantee I'll have you laughing. I would have had a worse day. I'll tell you my sad story, and you'll be fine, okay? One of the things that one of the people said about me in the lab when was asked about me is said, I don't know, when I think about her, I think whenever I looked up, she was always there. So if you were there 24/7, I was there 24/7 with you, okay? Mentor's key position is really, what do we need to do? A mentor is supposed to approach the mentee and say, what do we need to do? Where is it you want to go? What are your goals? This is a little bit different from being a coach, which refines something like a surgical skill. A coach would tell you, put your hand in more, do less this, smaller sutures, whatever. That's a coach. An advisor will say, take this course, take that course, blah, blah, blah. That's an advisor. A mentor is very different. We're not, at least for me as a mentor, I didn't try to make proteges. I try to take young people and help them become what they wanted to be. I didn't try to make little Judys around the world. I didn't want that. I wanted them to be independent. So the definition of a mentor is an accomplished clinician or scientist, an individual who is charged with providing, designing and managing your science, is also provides technical as well as interprofessional skills. And also the mentor helps you establish professional collaborations. That mentor introduces you to people who can help you and broaden your circle. That's their job. And you develop your skills as a writer and a critical thinker. I remember my first abstract. I had written it, I gave it to James Morgan. He came back, he wrote in red, it looked like he bled to death. Not one word, not one sentence was mine. And I asked him, why don't you just write it? Like, why am I doing this? But I learned, having seen him do that markup on my stuff. Muhammad in Egypt, that's what I do. With every email he sends me, I rewrite it grammatically correctly, because English is actually his fourth language. And then I send it back to him. I answer his questions, but I also fix it. And now, Muhammad yesterday sent me a 2-page email with not one grammatical error in it. He's got it. He learned it. He said, what do you do? He says, I'm studying it. And he did. He's got it. So you also develop those writer skills, critical thinkers, and also to become a balanced research entrepreneur. Entrepreneurs are risk takers, morally accountable, trustworthy. Simple as that. You're morally accountable for your work. They should be reproducible. Your lab director should not have to worry about, is that really the way the experiment went? And also they will help you develop your independent professional identity. Choosing them, first, the person has to want to serve as a mentor. I don't think you can make people be mentors. They also have the flexibility to make and define a commitment to you of time and effort. And also, they often have to recognize and subjugate, this is part, a lot of mentors in this room probably will disagree with me on this, the personal interest for those of the mentee. Now, what does that mean? An example is, I can give you one example in particular. I was invited to present at an international meeting, a big honor. I was assistant professor or whatever, and I was invited to present. My boss was thrilled. Chief of cardiology was thrilled. So, because all the heavy hitters were going to be there. So I said, well, most of the work would have been done by Roger, who was a medical student at the time, and I think Roger should present, and I'll go. And they said, no, You're the one with the reputation. We have a business class ticket for you, and fly. So, okay, fine. So I took the little invitation and I reprinted it and retyped it. And because Roger said he wasn't gonna go. He understood the politics of it. He said, no. So I changed it, put his name in it, said, I've convinced them. He sees his name as the presenter. I said, and here's your plane ticket, okay? Sure enough, we get there. I get off the bus, it's in Austria, and they said, oh, Dr. Gwathmey, we were looking forward to your presentation. I said, no, I'm not presenting. Roger's presenting. Well, my boss was there, and he was furious. Furious. How dare I bring a medical student to such an prominent meeting to present, who's never presented? And so, while we're sitting there, waiting for Roger's talk, I began to get nervous because my boss is threatening me, and I'm listening to all the other talks. And so I start hitting him, elbowing him. Do you know what you're doing? Do you know what you're doing? Are you ready? Do you know what you're doing? He's like, yeah. So now he's a nervous wreck, right? Like, please, what are you doing? He got up there, and I don't know, at that time, and he presented so well. And he asked every question, answered every question, okay? And then he sat down, and my boss leans over to me, Bill Grossman, says, you know, I thought you were good, but he is really good. I said, good. So then the meeting goes on, and Roger starts asking questions, and then he starts skipping us with the mics, because his questions nobody can answer, right? They start skipping him, because he was dominating this meeting. Okay, young person dominating. So yeah, sometimes I had to step aside. I didn't need another international meeting on my resume. I didn't. You know, it was his time to shine. It was his work. I thought he should take that position. And also, your mentor should have expertise in their area. So how do you choose the laboratory? You ask to see where the past trainees are, what they've done. How available is the mentor for meetings with the student? Who's responsible for teaching the techniques? Is the mentor going to teach it? The technician going to teach it? Another person going to teach us? Do the scientists and the labs, are they collaborative? Meaning, you know, what we would do in a lab, we would share parts of our experiments. So instead of having one abstract in a meeting, you'd have two. A guy would do part of somebody's experiment, they do part of mine, and then we have a name on two of them. Is it a fun place to work? Is important. There's a lot of politics and a lot of talking, standing around the water cooler talking, then that's not where you want to be. And what do they think? What do the other people in the lab think about their mentor? I mean, do they think they're good, fair, not fair? And are the resources, this is important, are the resources sufficient for you to accomplish your research goals in that laboratory? But also there is a mentee-mentor axis that people tend to forget. And also you really have to realize that at different stages in your life, you need different mentors, okay? So it's a very dynamic reciprocal relationship between the advanced clinician or clinician scientist that promotes actually the development of both. When you're successful, the mentor is successful. Your work reflects on the mentor. Your interactions at international meeting works with your mentor. This meeting I've released, I used to think it's released my mentees from constantly taking care of me at this stage of my career because they now mentor me. Okay, I say, well, you know, I've been offered this, maybe I should do this, maybe I shouldn't do that. Well, I need this, I need that. So they're now mentoring me. They're accomplished scientists, independent scientists in their own right. So now they mentor me. So it's very complex. You also have to learn the norms and the standards of what's right and what's wrong, the skills and behaviors and for them to develop as an independent researcher. So they provide their access to your network, as we talked about, security, guidance, words of always encouragement, humor. They should inspire you. They should give you hope, and they spend time with you. So for me, a mentor's biggest job is to serve as an advocate. Mentors should do things that you don't even know they're doing. For example, me as a mentor, if you're having a problem, my students may be having a problem with a particular teacher or a particular person or someone at the meeting that I know is just being a jerk to them. You will never see me. I'll go up to that person and say, hey, you know what? You really need to back off, okay? And this is about power and influence. I don't appreciate the way you're treating this one or that one. I've done this innumerable times, okay? I never tell the students, the mentee, that I'm doing it, and nor should I. They just know that their lives change. So you encourage and value each other, is centered, focused on the goal, understands what matters to the mentee, and is a good listener as well as teacher. But you have your own responsibilities as well. You as a mentee and a person, a fellow at ACIC, you have to know that one mentor is not going to meet all of your needs. You have to recognize that your needs change over time. And you also have the ability to accept and work through, and this is the hardest one, meaningful criticism. You have to work through it. It's not intended to be mean, okay? And you have to have an interest in working with mentors that will help you grow. And a commitment to make the development of a relationship, because it is truly a relationship. So your matrix for your success in ACIC is progress in your research, outcomes, publications, abstracts, presentations, and the ability to engage strong collaborators and mentors. You must create your own destiny. You do not see yourself as limited. You must be determined, and you also must be a risk taker. What I don't have here is you must be, in this day and age, morally accountable, meaning you have to be morally accountable for your data. And you must meet, and this is the thing I see people, like it says, sometimes you say, you need 7 publications to move to an instructor. People will target 7. This is crazy. No, you meet the criteria for success and you exceed them. You do not let yesterday's success, or you got a paper accepted, or you gave a presentation. You move on to the next thing, because if you do that, that complacency will lull you into failure. And that is absolutely a fact. I mean, you can't, I was this way. As soon as I get a promotion, oh, you're an instructor. I said, oh, thank you. What do I need to do now to be assistant professor? Oh, here, Judy, congratulations, you're assistant professor. Oh, well, what do I have to do to be associate professor? Okay, 30 minutes, then I come back. Okay, you should always strive to excel. And then you get to live the dream. And hopefully ACIC will allow you. Here's Patrick Thomas, MD. He's a surgeon, pediatric surgeon. Here he is with his patients. He's living the dream because he worked very hard. And here's Sergey, Russian. He just received a medal from the Academy of Science in Russia. And at first he was standing there like this. I said, Sergey, show me how you really feel. And that's when he goes, yes. And that's the way you will feel when you work and you're dead. And you're passionate about what you're doing, okay? Now, this is my last sentence, but I have to tell you, I would be remiss if I didn't tell you what's going to screw you up, okay? What is going to destroy you getting there? If you're not a team player. If you're not a team player, you're a control freak. Your track record, everybody's working on a team, your part is never finished on time. You have lots of excuses. You can't adapt. For example, Margaret started with the myofilaments, I started with calcium, we eventually met somewhere in the middle. I didn't stay in rigid on calcium, he didn't stay in rigid on myofilaments. You're arrogant, you're condescending. You never, ever, and I would hope, Dr. Vet and George, that your fellows, when they present, will not present with arrogance, but will present with confidence. People will recognize you for what you know. You don't need to yell it, you don't need to shout it, you don't need to say, I'm the best. They'll know you're the best, Okay, they will know from what you've done. And lack of integrity. The biggest thing that'll destroy you and bring you down, falsification of data, manipulation of the data, blah, blah. Don't do it. You're asking a question. The outcomes are the outcomes. That is what science is supposed to be about. Not, I have an idea and I proved it true. Okay? So, you have to think about where you want to sit on a bus. And here's a bicycle. You want to sit, everybody thinks they want to sit here. But look, this person has short-range vision telling her, oh, go this way. This person's reading a map saying, maybe up there, we should make a left or whatever. And this person's long-range visions. I think any and all of these positions, regardless of what position you play on a part of a team, it does not matter. You just need to play that position well, okay? And everybody will safely and successfully accomplish what the goals are. So keep lifting up people, helping people. The help doesn't hurt you, only broadens you and helps you grow. You should always do that. And that's what we learned quickly because we collaborated extensively in that lab. So, at the end of a year, you might have 10 abstracts because I did this part for this one. I said, go home, I'll do that part of yours, and so forth and so on. But if you're ever thinking about quitting, here's my phone number, here's my email address. This is FloJo. She was called FloJo. One of the fastest Olympics sprinters back in 1985. Her records have yet to be broken. It was her kneeling and praying. So I'm always running, but not like FloJo. So you should feel free if there's anything ever that I can do to not hesitate to contact me. And with that, Dr. George, thank you.